Hi, guys. Today we're on Unit 11, Lesson 4, and we're going to be introducing something called the power rule. So far, we've learned how to find the derivative of a function using the definition of the derivative, which is when we evaluate this limit here, and we wind up getting f prime of x, which is actually a rule to find slopes of tangent lines. Let's say, for example, we were asked to differentiate f of x equals x to the fifth. Now remember, you're going to be setting up this limit. And we'd have to plug in x plus h to the fifth power. And it would look something like that. Now just think about it. You're going to have to do, in order to evaluate this limit, we'd have to multiply that out and raise that to the fifth power. 1, 2, 3, 4. That's going to be a lot of awful work. Okay. We don't want to do this. There needs to be an easier way. Okay. In order for calculus to have developed the way it has, there has to be a different way to do this. Okay. So today we're going to learn one of the first shortcut methods, right? I kind of call this a shortcut method, which will make finding the derivative of function a lot easier. This method is called the power rule, okay? And it's used when you have something being raised to a power. And it's if f of x equals x to the n power, then f prime of x equals n times x to the n minus 1. We can also apply this rule if we have a multiplier out front. If we have a constant c times x to the n power, then f prime of x is going to equal c times n, whatever number's out in front, x to the n minus 1. Okay. And that's the notation for the power rule, but it's very, very easy to use. Okay. What we're going to do, move the exponent down in front of the variable and multiply by the coefficient that's in front. Subtract 1 from the exponent to get the new exponent. X just becomes a constant and a constant becomes 0. These are things we're going to see based on the rules, what happens. Okay. I just want to remind you right here that these shortcut methods, they came about from the definition of the derivative, but those proofs are way too long to show. So we're just going to use the rule. Just work through the examples. They're super easy. So we want to find f prime of x. And now again, we're going to use the power rule. We're not setting up the definition of the derivative. So instead of working out this big long thing up here, now we're just going to use this nice shortcut method. So f of x equals x to the fifth. F prime of x is going to equal, we're going to move my power down in front, multiply it by any number that's in front there. If there's nothing there, it's a 1. So 5x, and then we subtract 1 to get the new power. So 5 minus 1 is 4. So if we had evaluated that limit, probably would have taken us 15, 20 minutes, and we would wind up with the same thing. Okay, so this is a lot more efficient. And from this point forward, unless I ask you to use the definition of the derivative, you can use the power rule anytime you want. In example 2, if f of x equals 3x cubed, f prime of x is going to equal, we're going to move this power down in front, multiply it by the number that's already there, subtract 1 to get the new power. And that's our derivative function. And remember, that's a rule. We can plug in different x values and get the slope of the tangent line as we move through different points on the curve. F of x equals x. Okay. So let's just think about applying the rule. This really means 1 times x to the first power. So 1 times 1 is 1. X to the 1 minus 1 is 0. And x to the 0 is just 1. So anytime we have just an x there, with no power, it's really x to the first, this is going to happen. And your derivative is just going to be whatever constant is in front of your variable. So f prime of x, instead of going through all that nonsense, f prime of x is just negative, of negative 7x is just negative 7. Let's say we have something like pi in front of our variable, pi x to the fourth. Remember, pi is a number, so we treat it like a constant. So f prime of x is going to equal 4 times pi, which is just 4 pi, x cubed. And if f of x equals x to the 1/2 power, now I have a fraction power, but that shouldn't matter. Bring that 1/2 down in front. 1/2 x, 1/2 minus 1 is negative 1/2. Now, a lot of times we're going to ask you in the beginning, when we first start introducing these rules, to leave your final answer with positive powers. So we would bring that x down to the denominator. There could be times that we also ask you to put it back and write it with a radical sign. And if you recall from the other day's lesson, if we look at this function, this is really f of x equals the square root of x. And after we evaluated our limit definition, that's what we wound up getting, right, when we took f prime. Okay. Now let's talk a little bit about the constant rule. Okay. Our constant rule is if f of x equals c, then f prime of x just equals 0. Let's talk about why this happens. Okay. So f of x equals 4 is the same as saying f of x equals 4x to the 0 power. Okay. I know you don't really understand that because we don't really do binomial expansion anymore. It was in the old algebra course. But you would wind up, when you have a constant, you really have x to the 0 attached to it. So when I take this 0 and multiply it out front, my derivative is just going to wind up being 0. So that's just going to happen no matter what you do. So we just wind up whenever our function is a constant, it just goes away. It's just 0. Okay. Another way to think about this geometrically is if you think about the original function, f of x equals 4. And if you know that the derivative is the slope of the tangent line, well, this original function is just a horizontal line. And in a horizontal line, our slope is 0. Okay, so that's the kind of geometric connection. All you really have to remember is whenever you see just a plain old number in a function with no x attached to it, it just goes away. Its derivative is just 0. When we use the power rule, each term must have powers. That is, the function must be in exponential form. Some books will call this polynomial form. So we want to rewrite radicals as fraction exponents. So remember our exponent law, r x to the p power over root. We also have to rewrite the denominator. Let's say we have a power in the denominator. That's going to become x to the negative m. So let's just do a couple of quick examples here, and then we'll do some longer, more complicated things in just a minute. So if f of x equals 1 over x squared, with these problems, you're always going to rewrite in the proper form. So before we can take the derivative, we have to rewrite the original function. So this would become 1 over x squared is just x to the negative 2. Now I can take the derivative. So be careful of your notation. This is my derivative step. Negative 2x to the negative 3rd power. If the instructions say to rewrite it with a positive power, you're going to take and go one more step, flip the variable, change the sign of the exponent. if f of x equals the cubed root of x, we need to rewrite that with our fraction power. So that'd be x to the 1/3. Now f prime of x is going to equal 1/3 x, 1/3 minus 1. So 1/3 minus 3/3 is -2/3. And now, as a general rule of thumb, whenever our original function is given in a radical sign, our answer should be in a radical sign with positive powers, meaning I'm going to have to take this, put it downstairs, right? Put it down in the bottom with a positive power, and then rewrite it, because my original was with a radical sign, my answer should be with a radical sign. Okay. So those are things that we're going to practice. And those are things that, depending on as we move forward in the class, depending on what we're doing, we may leave our answers differently. But for right now, when we're just finding the derivative, we want to kind of go all the way back, positive exponents and radical signs. F of x equals, now I need to rewrite this, 6x, I'm in the denominator, so when I move it up, -2/3. So my derivative is going to be, I'm going to take this nice and slow with this one. I have -2/3 times 6x, -2/3 minus 1 is -2/3 minus 3/3. And then I'm going to clean this guy up. So -2 times 6 is -12/3. That would be -4 over cubed root of x to the 5th power. Now, all of this multiplying of fractions, you should be able to do in your head. We're not relying on our calculator. Okay. We're not giving decimal powers. Everything's going to be as a fraction. Okay. So far we've been taking the derivatives of functions that only have one term. Okay. Now remember, a lot of the functions we're going to be dealing with are going to have more than one term. All you have to remember is go each term one at a time and apply the rule. So if we're going to differentiate, f of x equals 3x squared plus 2x plus 1, our derivative function, one term at a time, 6x plus, if it's just 2x, it's just the constant. The derivative of 1 is just 0. So instead of having to do f of x plus h and work out all that mess, this is a much quicker, easier method to use. If f of x equals 3x to the 4th minus 7x squared plus x minus 11, again, one term at a time, apply the rule to each term. F prime of x is going to equal 4 times 3, 12x cubed minus 14x plus 1, and the 11 just becomes 0, so we don't have to include it. Now, all that can really happen is our functions just get a little bit, messier, but that shouldn't really matter. Take the original function, rewrite it in the proper form. 3x -3 x 1/2 plus 2. So f prime of x is going to equal -3 times 3, -9, x to the -4, 1/2, x to the 1/2 minus 1, -1/2, and 2 just becomes a 0. And depending on the instructions, you just want to be able to do this if you have to. Okay, most likely for the first test, I'm going to make you write it back to positive powers, square root signs. Let's look at one more example together. Rewrite, don't forget that rewrite step, it's critical. 2x to the -2 2x to the negative 1/3 plus 7x. Now I'm going to take the derivative of each term. Negative 4x to the negative 1/3. Negative 1/3 times 2 is negative 2/3. X to the negative 1/3 minus 1, negative 4/3. The derivative of 7x is just 7. The hard part here for some of you might be just this final rewriting part. X cubed. Remember, this is just a multiplier. It's just going to be its own 2/3, and it's the variable that has the power. Cubed root of x to the 4th. And don't worry if it looks a little messy like that. That's okay. We're not typewriters, so it might not always look pretty. Plus 7. And there's your answer. Okay. So that's a little bit of an introduction to the shortcut method for finding the derivative. You have a bunch of homework questions to practice, and we'll come back tomorrow and work on some other stuff. Thanks, guys. Bye.